Forms of heat in HVAC. Sensible heat. Sensible heat is defined as an energy that is transferred as heat to an object, changing the temperature but not its state. If we will measure the temperature of the warmth, then it is sensible. A body, solid, liquid, or gas, of mass m and heat c is heated to vary its temperature from T1 to T2 without changing its state. Indeed, the quantity or the pressure of the body is unchanged. The energy received by the body liable for its risen temperature is given by the relation Q is equal to m into C into T2 minus T1 in joules. Q is equal to m into C into T2 minus T1, 1055,06 in BTU. Latent heat. In contrast to sensible heat, latent heat is that energy that is released or absorbed due to the changes of the state of a body during a continuing temperature process. This process leaves temperature unaffected, that is, it won't get high or low. The four most common sorts of latent heat are fusion and vaporization. Fusion. Fusion is the passage of a body from a solid state to a liquid state. During the method of changing phases, the temperature stays equivalent. Energy is supplied to a solid so as to melt it, and energy is released from a liquid when it freezes. The simplest example is a cube melting at 32 degrees Fahrenheit, 0 degrees Celsius. Vaporization. Vaporization is the passage of a body from the liquid state to the vapor state. If conditions allow, the formation of vapor bubbles within a liquid, known as boiling. Heat must be supplied to a liquid to effect vaporization. If there is not enough heat, it's going to come from the system itself as a discount in temperature. The atoms or molecules of a liquid are held together by cohesive forces, and these forces must be overcome in separating the atoms or molecules to make the vapor. Water is a superb example because it can undergo fusion and vaporization. Take a look at the diagram below. Application in HVAC. In an HVAC system, we will check out the entire power like the sum of the sensible power required to lower the temperature of the air and therefore the latent power necessary to dehumidify this air. For a far better understanding of the concept of sensible and heat of transformation, let's check out this water diagram phase. Looking at the diagram, we will see that at stage 1, the water is solid. From stage 1 to stage 2, the ice is heated, and therefore the temperature increases. The energy spent is 16 BTU. Sensible heat. From stage 2 to stage 3, the ice is changing phase to become liquid. The energy spent now is 144 BTU. Latent heat. From stage 3 to stage 4, the liquid is heated once more, and therefore the temperature increases. The energy spent is 180 BTU. Sensible heat. From stage 4 to stage 5, the liquid is at saturation. It absorbed all the sensible heat. The more heat added will now change the liquid to vapor. The energy spent is 970 BTU, latent heat. Once all the liquid has changed to vapor, any longer heat added will increase the temperature of the steam as sensible heat. Finally, we observe that heat of transformation uses far more energy than sensible heat to vary the phase of a liquid, solid, or steam. This is it for today's video. Let us know in the comment section which topic you want to see next. Before leaving, check the exclusive offers, link in the description below. And do not forget to hit the like and subscribe button. To find out more on the subject, continue watching the next video.